Today we are starting the last unit, which we are back in your textbook. It is Unit 10, and we're starting off with combinations. And combinations you may recall from Algebra 2. We maybe briefly mentioned them earlier this semester, but we're kind of coming back to them full force. So let's go back and talk about what a permutation is. A permutation is an arrangement of teams, objects, etc., where order matters. And one other thing I want to mention, this is with replacement. So let's take a look at the first example. You've got 5 members who have volunteered to be on a board. They state the names of each of the members. 3 of them will actually be selected as board members. Suppose they decide to select a president, vice president, and secretary. How many different lineups, so notice here's the key word, lineups, and even more important, it's a lineup because these 3 jobs are different. So, order matters. We've got 5 people. We're choosing 3. I'm going to refresh your memory on the permutation formula. It's n factorial over n minus r factorial. So in this particular case, that would be 5 factorial over 2 factorial. 5 times 3 times 4 times 2. I can cancel those out, and finally I multiply them together. Obviously you have that button on your calculator. You're more than welcome to use that as well. So again, we would have 5, choose 3, and again we end up with the same answer, 60. Now, question B, it says, what if they decided just to make a governing committee? How many combinations would we use? The only difference between combinations and permutations, combinations is when the order does not matter. So, in this case, we're doing combinations of 5, choose 3. Let me show you that general formula here, and let's think about why that makes sense. If I had n, choose r, I still have n factorial. I still have that n minus r factorial, but what I have to divide out are those duplicates. And the way we divide them out is by dividing by r factorial. So we're actually going to end up with a lower number, which would make sense because in this case the order doesn't matter. So again, just using that definition, I have 5 factorial. 5 minus 3 would be 2 factorial, and 3 factorial. I'm going to go ahead and expand it out. I'd have 5 times 4 times 3 factorial, which I can stop there, over 2 factorial. So really I have 5 times 4, 2 times 1, and I end up with 10. Now it says Felicia decides she wants to volunteer as well. How many possibilities are there for the lineup of officers now? So really what we're referring back to is A. The only difference is Felicia wants to volunteer as well. So now we've got permutations. We've now added in a 6th person, but again we're only selecting 3. Go ahead and plug that in my calculator. We end up with 120. How many different committees are there possible with Felicia too? So that again refers back to this one right here. We're doing combinations of 6, choose 3. End up with 20. So really we talked about these next few things. We said a combination is still an arrangement. However, in this case, it is when the order doesn't matter. I also included the formulas up there, but again, let's write them down formally here. We had n choose r. That's n factorial over n minus r factorial. For combinations of n choose r, again, n factorial, n minus r factorial over that r factorial. And just like previously, we'll give you these general formulas as well. Okay, moving on to the back side. So we've got 8 different questions we have to figure out. Are these permutations or combinations? And then actually go ahead and solve them. So I'll take a look at a few. You guys can discuss them in your group, and then we'll go down to some of these numerical ones at the bottom. It says Castell and Joe planning trips to 3 countries. There's 7 countries. One trip will be 1 week long, another 2 days, and the other 2 weeks. So does the order matter? It does, because depending on which trip we do, it will be a different length. So order matters. That means we are doing a permutation. So we've got permutation of 7, choose 3. And I'm coming up with 210. There are 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? So does the order matter when we're shaking hands? It does not. That means we've got combinations here. So we've got 110 people, combinations, and they're really just shaking hands with 109 people because they're certainly not going to shake hands with themselves. So 110, combination, 109, and we end up with 110. That number seems awfully low. I might have to come back to that. Number 3, a group of 25 people are going to run a race. The top 8 finishers advance to the finals. The question is, does the order matter with those top 8 finishers? It really doesn't, because it says they're still going to make it to the finals. So it doesn't matter whether you're finisher number 1 or number 4 or number 5, you're still going to make it to the finals. So that's a combination. So we are doing combinations of 25, choose 8. Let's go down to question number 6. 6 is very similar to the front. Notice again, when you're selecting these people, they have specific jobs. So the order does matter, which implies permutation. We've got 10P4. Let's go down to question number 8. I want to point out here the top 3 runners, gold, silver, and bronze. That would imply the order matters, so again, we've got permutations. Okay, let's go down and take a look at some algebraic ones, and we saw some of these actually got n plus 2 over n minus 1, and we're solving for the missing variables. And I don't think there's a missing variable here. I'm thinking we're just going to simplify. So we're going to start with the larger one. So that means we would have n plus 2, n plus 1, n, and then when we get down to n minus 1, we can stop at n minus 1 factorial. So those two cancel out. As I said, we don't have anything it's set equal to, so we're going to assume it's just the algebraic expression n times n plus 1 times n plus 2. Okay, moving on to number 2. This one does look like we're going to solve. So again, we're going to start over here. One other way we talked about this earlier was this means we've got n and we're choosing 5. So if you can envision, we've got 1, 2, 3, 4, 5 slots. I'm starting off with n minus 1, n minus 2, minus 3, and minus 4. On the other side, same thing. I'm starting off with n and I'm selecting 3. So that would be n minus 1, n minus 2. Now the reason we can do this, as you can see, we can start canceling some things off. All 3 of these are going to cancel off with all 3 of those. So we are left with, I'm going to go ahead and multiply that out, n squared minus 7n plus 12 equals 42. This is quadratic. I know that because it's a degree 2. So we're going to bring over that 42, set it equal to 0. And it looks as though we have n minus 10, n plus 3. From here, we'd end up with n is 10, and from here, we'd end up with negative 3. But we can't have a negative group size, so we end up with 10. Okay, the last one, I can't get it to work out as it exists, so I'm going to change it up a little bit. We're going to cross all of this off, set this equal to 18, and I'm going to change this to a subtraction. Now, one nice thing about this introduces another way that we can show the combinations and permutations is with this kind of bracket form. So what this means, corresponds with the group that you're starting with, and this is the size that you're ending up with. So in other words, I've got this many items and I'm selecting 2. So if you can envision, I've got n minus 2 and n minus 3 because I have to go 1 less. So let's go ahead and multiply that out. That's n squared minus 5n plus 6. I'm going to subtract, and again, take a look. You've got n minus 3 times n minus 4 because again, you're selecting 2. So let's go ahead and FOIL that out. N squared minus 7n plus 12 is equal to 18, and now we've got an equation to solve. Notice you've got n squared minus n squared cancels out. Negative 5 minus negative 7 would be a 2n. 6 minus 12 would be a negative 6 is equal to 18. Finally, we can solve. We get 2n equals 24, and finally n is equal to 12. Now this one we could check on either calculator. We're saying that we think this is equal to 12. So take a look. 12 minus 2 would be 10, so we're saying 10p2 minus, again, if I plug in 12 here, 12 minus 3 would be 9, so that's 9, choose 2, and we're hoping it's equal